Hey guys, today we will be looking at the quotient rule. So, what is the quotient rule? So, imagine you have a function h of x and it is equal to f of x divided by g of x. So, if you want to differentiate this function h of x, then you would need to use the quotient rule. And the quotient rule is h prime of x is equal to g of x times what you will get if you differentiate f of x, which is f prime of x, minus g prime of x. So what you will get if you differentiate g of x multiplied by f of x, all divided by g of x squared. To just simplify the notation here, let me say that f of x is equal to u and g of x equal to v. That means h prime of x now is equal to g of x is v and f of x is u, but because we are differentiating it, it will become u prime minus g of x is v, so if you differentiate g of x, then you'll get v prime, and f of x is just u, all divided by g of x is v, and you square it, so v squared. So now let's look at some examples. So example 1 is f of x is equal to e of x divided by e to the 3x plus 3. So we want to differentiate f of x. So f prime of x is equal to, first, so e to the x is u and e to the 3x plus 3 is v. So we will multiply v by the differential of e to the x, which is just e to the x. So this will just become e to the x multiplied by e to the 3x plus 3 minus, so now we need to differentiate v and multiply it by u. So when you differentiate v, you will get 3 e to the 3x multiplied by e to the x over v squared, which is e to the 3x plus 3 squared. So we can simplify this. So e to the x multiplied by e to the 3x is e to the 4x Now you can multiply e to the x by the 3, so that will give you 3 e to the x. And now this will be e to the 4x, right? All divided by e to the 3x plus 3 squared. So now we can simplify this further into 3 e to the x. 1 minus 3 is negative 2 e to the 4x, all divided by e to the 3x plus 3 squared. So now let's move on to the next example. So here we have f of x is equal to ln of x over x, where x has to be bigger than 0. This is because ln of x is only defined for values that are bigger than, for x values that are bigger than 0. So to differentiate this, so now we have u is equal to ln x and v is equal to x. So u prime is just 1 over x and v prime is simply just 1. So f prime of x is equal to x multiplied by 1 over x minus the 1 multiplied by ln x, so that's just ln x, all over x squared. If you look here, we have x in the denominator and x up here, so we can just cancel these guys out and we will be left with 1 minus ln x over x squared. The next example is g of x is equal to sin x over x, and here x cannot equal 0 because you can't divide by 0. So we can say u is equal to sin x, therefore u prime is equal to cosine x, and x we can say it is equal to v, so v prime is equal to 1. So if we now differentiate g of x, we'll get g prime x is equal to g of x. So we had to multiply v and u prime of x first. So multiplying them two together will give us x cosine x. Now we had to minus, and we have to multiply u by u, so sin x, by 1, which is just sin x. And this is all divided by v squared, which is x here, so it's x squared. Again, you can't have x as 0 in this denominator because you cannot be dividing by 0. So the next example is h of x is equal to tan x. So you might be wondering, how can we use the quotient rule to differentiate tan x when we don't have a function on the numerator and on the denominator? Well, we can write tan x as sine x over cosine x. And now we have two functions of x on the numerator and the denominator, so we can now use the quotient rule to differentiate tan x. So we can say that u is equal to sine x, therefore u prime is equal to cosine x. We can say v is equal to cosine x, and therefore v prime is equal to negative sine x. So h prime of x is equal to cosine x times cosine x, so v times u prime, so cosine x times cosine x, which is just cosine squared x, next we will be minusing u times v prime, so we will get negative sine squared x, and because there is a negative sign here, this will become a positive and sine squared x. All divided by v, which is cosine x, so cosine squared x. So from this, the top simplifies to just 1, and we will have cosine squared x, the denominator. 1 over cosine x is secant x, so 1 over cosine squared x is just secant squared x. That's all the examples for today. If you do like this video, please do like and subscribe, and share it if you want to.